Advanced Technology Background Details by Connor Kearney. With the DirectX 11 Skifree, the features include a 3D cube created from several triangles combined together being textured on each side from the resource file. This was done using the graphics pipeline using several stages and shader techniques to create vertexes on the screen that combine together to represent a cube shape, with a filled-in texture between the vertexes showing a face and a texture on each face. Some crucial steps that was used to create the object was vertex shader, pixel shader, and buffers to correspond with each shader, from vertex buffer to the index buffer. Creating the texture was from a shader resource view from file and held within the resource file using a color map to replace the flat color with a texture. I also created a movable 2D square with transparency and a semi-layer effect. This was done using the created 2D sprite from the use of the graphics pipeline via pixel shader and vertex shader and putting them as one object. Using this single one sprite object, I could relocate the object on a semi-layer system that uses set position float to move the sprite image as a whole, bouncing between the screen size barrier at a set velocity using X and Y coordinates. If one sprite was under the other image layer, a semi-transparency can be seen. This is due to the color map and sample overlapping with each sprite. An early engine was created to hold systems. I established an early engine to control the rest of the project, which held the important systems that needed to be established, the shaders or buffers. I created a class for holding these systems that would run later in the program. Then systems would be able to pass any shader or buffer to any part of the project. This engine would be from loading content to uploading to updating to rendering the final outcome. With the Squad AI controller, the features include the ability to control 3 separate dog companion AIs to follow your direct order or follow their own instinct on the field. This is done with a nav mesh agent controlling their path finding and movement using a similar speed to the player's movement. Using the UI formation button, you are able to change position of the dogs to surround the player with an assorted selection of formation. This is done with several invisible game objects that is located on the player model, which the navmesh set destination uses with a switch case statement that is linked with the button number. Number can be seen on the UI button. Each individual dog AI can change their behavior depending on the player or freedom selection of the AI. Behavior are aggressive, defensive, flee, and freedom. This is done with a button underneath each of the dog's portraits that will cycle between each behavior. Behaviors are self-explanatory except the freedom option that allows the AI to control its own path and behavior style depending on the health and the amount of friendly or enemies around them. All AI dogs and wolves have a cone of visibility to detect each environment object, friendly and enemy AI. This is done using the Unity engine editor to be able to see the raycast position. Using a raycast which gets the view angle, it will find the middle point and then raycast off that and find the middle point again repeatedly until the ray hits an object within the game scene. This gives the cone a better, more precise angle. Water simulation, the features include a wave system with a randomization increasing and decreasing the height, giving a gentle or harsh wave effect. This is done with a gradient noise effect that is on the plane object that gives it a haphazardness random wave going up and down. Noise is combined with the time tiling offset and the wave speed value on the position to give the wave effect more of a gentle experience, while occasionally a rough harsh wave will appear. The foaming system will give objects within the water or around it a white area boundary that slowly lessens the deeper it goes depending on the camera position and if the water collides with it. This is done using the camera and the world space position of the plane that is remapped into a smooth step while using the screen depth area to locate the highest point and the lowest point. The system is also split off the main water effect to give a foaming to itself transparently and any other objects that collide with the plane. Thick wide rippling effect can be seen on top, separating the blue water with semicircle pattern rippling the water system. This is done by using the main water effect system and adding a boroid with a radical shear, making the cell density separated into a smaller area, while using a power node to make the cells large enough to make the main water system still stand out and the rest of the area becoming the ripple. Inside the water there is a two-tone color showing the depth effect from the highest to the lowest position in the water. This is done by using a subgraph from the main shader water graph that combines the screen depth and the screen position to figure the depth of the plane. This is then lerped with two colors, higher and lower, in the main graph. Separate from the water shader graph, I also created an underwater environment effect. This effect was created using a global volume using the addition of post-processing to create a unique visual that adds overrides to change the perception of the user's camera. Thank you for watching.